All right, sorry y'all. We're going to keep going on this. I'm sorry that last video got a little long. So we are still in 4A, which is Introduction to Probability. So here's an example problem. So in an attempt to increase sales, breakfast cereal company decides to offer a promotion. Each box of cereal will contain a collectible comic book featuring a popular superhero. The company claims that 5 comic books are equally likely to appear in each box of cereal. A superfan decides to keep buying boxes of cereal until they have all 5 superhero comic books. The fan is surprised when it takes 23 boxes to get a full set of comic books. So it says, does this outcome provide convincing evidence against the company's claim that comic books are equally likely to appear in each box of cereal? So I think I mentioned this in the previous video, but right now we're going to say convincing evidence is less than 5% of the time. So we're looking for anything that is less than 0.05 when we're looking at probability. All right. So it says, to help us answer this question, we want to perform a simulation of the probability that it will take 23 or more boxes to get a full set of superhero comics. So here we go. Right now, this says, describe how to use a random number generator to perform one trial of the simulation. So if I'm going to use a random number generator, I'm going to say, let 1 equal, let's see, who's our first comic? The Flash. And 2 equal Batman. 3 is going to be Superman. 4 would be Wonder Woman. And 5 would be the Green Lantern. Okay, so how would I do this? I would generate random numbers 1 through 5 to simulate one box of cereal and the corresponding comic book. Then I would say keep generating numbers from 1 to 5 with repetition until all 5 comic books are collected. Repeat this simulation 99 times. All right, so and I had looked ahead to this where it says we carried out 100 trials. So that's why we would repeat this simulation 99 times. So we carried out 100 trials and we noted the results below. So here is what this looks like. They put this on a dot plot, so it makes it super nice to see. And so it says here, explain what the dot at 18 represents. So I have this dot right here at 18. What does that represent? So I would say in one trial of the simulation, it took 18 boxes of cereal to collect all 5 comics. That's what that's saying right now. Okay? So now it says use the results of the simulation to estimate the probability that it will take 23 or more boxes to get a full set of comic books. So if I look up here, this would be 21, 22, 23, 24, 25. So if I want 23 and greater, it's going to be that area. And so what that gives me is I would say the probability that it is greater than or equal to 23 boxes is going to be 3 over 100. There were only 3 trials that were greater than 23. So 3 out of 100 would be 0.03. Okay, now this 0.03 is the same as 3%. Now, if we go up here, what it's saying is there convincing evidence against the company's claim that 5 comic books are equally likely to appear in each box of cereal? So when we have this 3% is less than 5%. So what we know here is this is less than 5%. So let's go down here and look at this. Based on the actual result of 23 boxes, now what we're not doing is we're not saying, like if you look at this, we can look at this data and we can find, you know, where our mean value is in here and get an estimate of, we can look at this data, get a mean estimate of where our data is to tell us about how many boxes of cereal is the average. But this is asking specifically based on the actual result of 23 boxes. And your answer in this previous question, is there convincing evidence that the 5 superhero comic books are not equally likely to appear in each box? So here's my justification. All right, here's the important part. Because it is unlikely, and what I would say here is probability is less than 0.05, so my probability is less than 5%, that it would take 23 or more boxes to get a full set or all 5 comic books. By chance alone, right? Because it is unlikely that it would take 23 or more boxes to get all 5 comic books by chance alone when the comics are equally likely to be included. And we know that from our original statement. So they're saying that they're equally likely to be included. This result provides convincing evidence that the comics are not equally likely to appear in each box. So because it's unlikely, we got 3%, this is 5%, is unlikely that it would take 23 or more boxes to get all 5 comic books by chance alone when the comics are equally likely to be included. This result provides convincing evidence that the comics are not equally likely to appear in each box. Okay? Let's try one more. So I pulled this out of your textbook, and I thought that this was really good because I noticed in the last unit, a lot of times when you would do a random number generator, you would say generate numbers from 1 to 95. Remember, every label needs to be the same length. So we would say if you're generating numbers from 1 to 95, then our random number generator, when we talk about it, has to be 0, 1 to 95. So this has to be 2 digits. We can't say 1 to 95. So just remember that. I thought I would throw this in there just as a reminder. Okay, so we have another example right here, And this is where we're going to use a row of random numbers. So what this says is, at a local high school, 95 students have permission to park on campus. Each month, the student holds a golden ticket lottery at a school assembly, and 2 lucky winners are given reserved parking spot by the school's entrance. Last month, the winning tickets were drawn by a student council member from the AP Stats class. Both golden tickets went to members of that same class, and some people thought the lottery had been rigged. There are 28 students in the AP Stats class. Perform a simulation to estimate the probability that a fair lottery would result in 2 winners from this AP Stats class. So describe how you would use a random number digit to carry out the simulation. All right, so what I would have here is I have a total of 95 students. And of those 95 students, I have 28 in AP Stats. Okay, so if I wanted to use this random number generator, I would say label AP Stats students 01 to 28. Label the remaining, so remaining students 29 to 95. All right. Numbers 00, 96 to 99 would be skipped. Now, why do I have to say this? I'm going to run a random number generator from 01 to 95. Now, if I do that on my calculator, it makes it easy because I can go over here and I can go down to a random number generator and I can say between 01 and 95, and I can run this specifically to get double-digit results, okay? But I am using a row of random digits. So I can't just say any 2 digits. I have to say 00, and 96 to 99 would be skipped. Okay, using the random digits row, select 2-digit pairs, and record results skipping repeats, or do not allow repeats would probably be better to put this. And then I would say record if the student was in AP Stats. All right, and then we can say perform the simulation, I don't know, 20 times, 50 times, 100 times, many times. That's what we're looking for, many times. Okay, so this says perform 3 trials of the simulation using the row of random digits. Make your procedure clear so that someone can follow what you did. So first number here is going to be 70. The second number here is going to be 70. So I'm going to skip the second 70. Okay, 70 is a repeat. My next number here is going to be 84. And then 10. And then I have 98, so I'm going to say skip 98. And then I have 55. And then 18. 19. Okay, and I skipped 98 because it was too big. All right, so I ran this simulation 3 times. So here's the first. Remember, I'm picking 2 2 people get the golden ticket. So here was my first simulation, 70 and 84. So 70 and 84. So I have no AP Stat students. Because remember, my AP Stat students are just 0 to 28. So in the second one, I have the numbers 10 and 55. So I have 1 AP Stat student. And here I have 18 and 19. So I have 2 AP Stat students. Okay? In 9 of the 100 trials of the simulation, both golden tickets were won by members of the AP Stats class. Do these results give convincing evidence that the lotto was not carried out? Explain your reasoning. So 9 out of 100 trials. So 9 out of 100 trials would be 9% of the time. It is not unlikely. So there is not convincing evidence that it was unfair. Now remember this 9%, so 9% is greater than my 5%, and so that's why we say that this is not convincing evidence. Okay?